Hello everyone. What is current? Current is the flow of electrical carriers like electrons. If you check those two wires, those two endpoints, when we got them closer to each other, there's a spark. This spark means that there's electrons are moving from one side to another. Okay, now if you want to understand currents, let's first differentiate between a low current and a high current. Since the current is the carrier moving in a closed path, that means if there's lots of them, lots of electrons are moving, then there's a high current, and current is evaluated with the unit ampere. So if we have, let's say here, 100 ampere, while here we might have 1 ampere. 1 ampere is a low current. Now in real life, 10 ampere, 12 ampere, 50 ampere is a high current. Why? Because electronics, like the devices like calculator or some ICs in the computer, they use low currents, like you're talking about milliampere. That means 10 to the power negative 3. Okay, now what's the requirement of current? A current to move in a wire, first you have to have a closed path. So if we have this switch, if you turn on the switch, then it's like you connected the wire between those two ends. And if it is connected to a power supply, a battery, then you have a closed path and you have a voltage source which is a battery. So it needs two conditions. Whenever you switch on and then there's a battery or a source, then that light would goes on. And what happens through the wire? There's electrons are moving. Okay, for the current, what equations it involves in? First, since it has something to do with electrons, then the number of electrons that passes in a unit of time, that would give you a current, which is Q over T. Q is the charge and T is the time. So Q over T is the current, which is the rate of electrons moving in a unit of time. The unit would be coulomb per second. It also relates to a voltage using Ohm's law. What's voltage? We will discuss that in next lecture, but let's say it's a battery. Okay, it's the value or the potential difference in the battery. So I would relate through Ohm's law to voltage and to a resistor, the resistor we took in last video, and it would be I equal V over R. It will also relate to a power. The power relates by, if I divide the power over voltage, that would give you current. We will also talk about the power in not the next video, the next one. Finally, I want you guys to differentiate between two terms. We always hear those, DC and AC. DC circuit, AC circuit. DC means direct current, AC alternating current. Now from that word direct, we know that the electrons would move in only one way. It will move only in one way. If we see those pictures, those two pictures, that DC means the electrons would move either to the right or to the left, while the alternating current, it will move in both direction. So here the electrons will keep reversing their direction. Normally they reverse 50 to 60 times every second. Okay, now some applications for the DC is just like small gadgets or toys. Like most of the toys, kids toys, they use DC current. Okay, and the battery that we buy, like the AAA or the 2A, this is a direct current battery. It just directs the electrons in one direction. Okay, while the alternating current, we said it keep reversing the direction. Okay, since it keeps reversing the direction, how would it like work to let's say light up light bulbs or whatever? Now if I give you this example, this is a lamp, and the lamp normally has a filament. This filament, when it heats up by the energy of the electrons that goes through it, it would give it would convert the heat to a light that we will see. Now if you think about the direct current would make sure the electrons would keep flowing through the filament, and then the light would goes on as soon as we connect this circuit and we have a battery connected. While the alternating current, the electrons would keep reversing their direction, but still they would go through the filament. Like there is energy, since there is movements, constant movements of electrons, even if it's forward and backward, but since there's a movement, there's energy, the filament would heat up and then the light would goes on. Now some applications need to convert from AC to DC because they only work in DC, or while some application the other way, vice versa, they need an AC. So if you have a DC, you have to convert it to AC, and there's a setup to do that. We will learn it maybe in different course. So next video we will talk about the voltage, so stay with us.